Hello everyone, welcome to my calculus lecture. In this lecture, we study related rates. Related rates problems often involve real-life applications of the chain rule or implicit differentiation. So why they are called related rates? Because these problems usually involve two quantities that have a functional relationship. We are going to go over some of the examples that are commonly seen in calculus textbooks. Okay, so here's the first example. Car A is traveling west at 50 miles per hour, and car B is traveling north at 60 miles per hour. Both are headed for the intersection of the two roads. At what rate are the cars approaching each other when car A is 0.3 miles and car B is zero point 0.4 miles from the intersection? So that's the question. So let us take a look at the, the following figure. Okay, so this picture shows you, depicts what's described in the question. Okay, so here there are two quantities. Okay, x and y given. Okay, so x here represents distance, right? Distance from the intersection to the car A, and y represents the distance from the intersection to the car B, right? So this distance here. Uh, Excuse me. There is another quantity z. Z is a distance between A and B, as you can see. So x, y, z, as you can see easily, they form a right triangle. Okay, right. So to work on this problem, we are gonna set just now. So we are going to introduce the three quantities, right? X, Y, Z. So X is, let me write that down again. Distance from the intersection to car A, and Y represents distance from the intersection to car B. And Z is the distance between car A and, and the car B. Okay, so the since x, y, z from the picture earlier, right? They form a right triangle. Obviously, there is a what is that? Pythagorean relationship, right? Between those. In other words, since z is the hypotenuse of the right triangle, we have by Pythagorean law, z squared equals x squared plus y squared. Okay, so we are going to differentiate this. remember here, x, y, z, these are all functions of, the time t, right? So, to differentiate this, we have 2z dz dt by different implicit differentiation or the chain rule, same thing. The right hand side, I have 2x dx by dt plus 2y dy by dt. Okay, we have those things. So, the uh, all of them have 2 in common, so, we can cancel that out. Okay, so in other words, we divide uh, the whole equation by 2. So what we are trying to find is actually dz dt, right? dz dt. So, if we solve this for dz by dt, that's what we are trying to find. So that's going to be 1 over z multiplied by x times dx dt plus y times dy by dt. So once we know all these quantities, right, x, y, z, dx by dt, dy by dt, then, we can calculate dz by dt. So let's go back to the question again. We are trying to find what, the uh, the rate at which the two cars A and B approaching each other. So we are trying to find the dz by dt when the car A is zero point 0.3 miles from the intersection. So when x equals 0.3 and also when car is 0.4 miles from the intersection, so when y equals 0.4, so we know that. And also, the car A uh, the speed dx by dt, that's 50 miles per hour, right? But actually, it's a negative 50 miles per hour. Why negative sign? Because, this car A is approaching. So car A is approaching the intersection, right? So the distance from the intersection to A gets smaller and smaller. So the speed is actually decreasing. Because of that, we should include the negative sign. Likewise, dy by dt, that is also negative, right? Here, that's given by 60 miles per hour. So we know all those things, right? What's not written or given is actually z, right? But that can be easily found because z is related to x and y by Pythagorean law. So when a equals 0.3, b equals 0.4, you can easily find z quantity. In fact, if you remember, this form, a right triangle, and right triangle case, what is that? 3, 4, 5, there's ratio, well-known ratio, right? So even without even calculating, you won't know if you remember that. Z would be 0.5, right? But of course, you can uh, calculate, sorry, you can calculate that using Pythagorean law as well. Okay, so here's what we have. So, let us write down what we know. So, x equals 0.3, right? And y equals 0.4, and z, again, if you remember the well-known ratio, that's going to be 0.5. Otherwise, you can use this, the Pythagorean, the identity, right? So the plug in x equals 0.3, y equals 0.4, you will find this equals 0.5, all right? And what else? dx by dt, that's negative 50, okay? Negative 50 miles per hour. dy by dt, that's negative 60 miles per hour. Okay, so we now we have all the quantities we need to know, right, to calculate this. So just putting those values, right, we will have the following value. So this is going to be negative 78, negative 78. Of course, from the picture, it is clear that the distance, the z is also, what is that, decreasing as well, right? As car A and car B are approaching, the intersection. So obviously dz dt is going to be negative 2, okay? That's something expected, miles per hour. Okay, so that's going to be the final answer. Uh, Next examples, right? So there are three of them listed here. So let us take a look at like one by one. So first one is the following. Uh, Air is being pumped into a spherical balloon so that its volume increases at a rate of 100 cubic centimeters per second. How fast is the radius of the balloon increasing when the diameter is 50 centimeters? Okay, so that's the question. Okay, so to work on it, let's get back to my notepad. Okay, so for this question, let us denote the volume of the balloon, right, by V, big V. So that's the volume of the spherical balloon, and R, little r, is going to be the radius. Okay, and as you know, the volume of a sphere, right? A sphere is 4/3 pi r cubed, right? Pi r cubed. So that's the volume of a sphere with radius r, right? So we differentiate this. So, in this case, the volume is a function of radius, right? So let's take the derivative. Okay, so dv dt. So we differentiate this equation with respect to t. Remember, in this case, both the v and r is a function of time t, right? Because air is being pumped into the balloon, so balloon gets radius gets also the increasing, and the volume is increasing also in time. Okay, so both are functions of t, but then at the same time also v and r are related, right? So they also have a functional relationship. So anyway, in this case, dv dt equals, so right hand side, we also we have to use the what is that? The implicit differentiation. So that's going to be, first we differentiate this with respect to r, so we get 4 pi r squared, and then you have to multiply by dr dt because we are actually differentiating with respect to time t. Okay, so that's the dv dt, right? So what in the question, okay, let's get back to our question again. So we are trying to find out how fast is the radius of the balloon increasing. So what we are trying to find is dr by dt. Okay, so uh, we are going to solve this for dr by dt. So dr by dt is going to be 1 over 4 pi r squared times dv dt. Okay, so we are trying to find the dr by dt when, so here, the required quantities are r equals the diameter is 50 centimeters, right? So which means that the radius is going to be half of it, 25 centimeters. Okay, and also dv dt is given. Okay, that's 100 cubic centimeters per second, right? So r equals 25 centimeters, and dv dt equals 100 cubic centimeters per second. Okay, so you put these quantities here, for r and dv dt, we get, that's going to be 1 over 25 pi. Okay, 1 over 25 pi. The unit is going to be centimeter per second. Okay, so that's a pretty straightforward question. Okay, so next question. So next question is the fish population. It is denoted by capital N, big N, in a small pond depends on the amount of algae. In this case, so it's denoted by little a measured in pounds in it. So the equation modeling the fish population is given by the following equation. Okay. So the question is if the amount of algae is increasing at a rate of 2 pounds per week, 2 pounds per week. So in terms of A, so that's going to be dA dt positive 2 pounds per week. Why 2 positive? Because that's increasing, right? So in that case, at what rate is the fish population changing when the pond contains 5 pounds of algae? So when A equals 5, okay? So this also looks pretty straightforward question. Okay, so for this question, right, and the fish population, okay, right, is modeled by the following equation, 3a squared minus 2a plus 26 to the power 4, okay? So we are trying to find what dn by dt, okay? dn by dt. So if you differentiate this, that's going to be 4 times 3a squared minus 2a plus 26 cubed, and then you have to multiply this by derivative of inside the parentheses, right? By chain rule. So that's going to be 6a minus 2, right? 6a minus 2. Okay? And then, again, we're not taking derivative with respect to a, but we are taking derivative with respect to t. So, one step further, you also have to multiply that by dA dt, okay? Right. So, as a summary, you see, this is n is a composite function. N is a composite function of, the, what is that? Three functions, okay? Three functions. Because, n is a function of a, n is a function of a, but then a is a function of t, all right? So if you, in this case, the innermost variable is t, time variable, and if you are taking, so if you are actually taking derivative of n with respect to a, this is where you would have stopped it. But we are taking the derivative of n with respect to the inner, the most variable, which is time t, right? So you have to apply chain rule once more, right? So that's how we get this. Okay, so so derivative part is done. Now we have to get the numerical value. So here, what's known? We have dA by dt, right? dA by dt, that equals 2 pounds per week. 2 pounds per week. And A, we are trying to calculate that, when the amount of algae, right, becomes 5 pounds. Okay, right. So those are the only quantities that are required to evaluate this. So here, the n, putting all those things, dn by dt is obtained by negative 80 pounds per week. Huh. So what do you see? Since we get negative value, that means the fish population is decreasing. Okay. So, if we interpret this, what this means is the fish population is decreasing by 80 pounds per week, at the instant when the pond has 5 pounds of the algae. Okay, so that's interpretation, the interpretation of the quantity we obtained. Okay, so next example. The retail price per gallon of gasoline is increasing at $0.02 per week. The demand equation is given by the following function: 10p minus square root of 356 minus x squared equals 0. Here, p is the price per gallon in dollars, of course, uh, when x million gallons are demanded. Okay. At what rate is the revenue changing when 10 million gallons are demanded? That's the question. Okay, when 10 million gallons are demanded. So when x equals 10 million gallons, right? At what rate is the revenue changing? So what is revenue, right? We need to know what the revenue is. Uh, so let's get back to my notepad. I'm gonna move to next clean, nice clean page. Okay, so here total revenue. So this is something you would have to recall. So total revenue R, we usually denote it by R. Total revenue R in basic economics, right? Basic economics, total revenue R is given by R equals the demand X times price. Okay, so X times P. That's the revenue. Okay, so we are in the question. So we are trying to find uh, what is that? The right. So at what rate is the revenue? Right, is the revenue. So dr by dt. That's what we are trying to find. So we will have to differentiate this. So again, R is related by x and p, but then both x and p are also function of t. Okay, so dr by dt. So using product rule, that's going to be dx product rule and chain rule dx dt times p plus x times dp dt, right? dp dt. No, actually, in this case, no, I mean, no, we don't have to use it, right? I mean, chain rule is not needed, okay? So it's just simply, because that's linear, right? X and P, both are linear. So the functions, so the we don't need the chain rule, but just the product rule. Anyway, so we're gonna need these quantities, right? dx by dt, p x dp dt. Okay, so right. So x is known. X is given in the question. So actually x equals 10 million gallons, right? 10 million gallons. Okay, so we need to find the p dx by dt, okay, and also dp dt. So the p and x, right? The price and demand satisfying the following equation, right? So 10p minus square root of 356 minus x squared equals 0, right? So to find the dp dx, dp dt, we differentiate this. So we differentiate this equation with respect to time variable t. So we get 10 times dp dt, right? dp dt, and then negative, we have 1 over 2 times square root of 356 minus x squared, and then you will have to multiply this by the derivative inside the radical, right? So that's going to be negative 2x here, using the chain rule, of course. And then right-hand side is going to be 0, okay? So, all together, right, after simplifying it, dp dt plus x over square root of 356. Oh, you know what? I missed something, right? I missed something because we are not taking derivative with respect to x, but with respect to t. So I missed something important. You have to multiply by dx by dt at the end, right? Equals 0. So here, of course, I have dx by dt equals 0. Okay, so in this case, so with x equals, I'm not gonna write down the the unit million gallons, but x equals 10, and we also know the x by dt, right? Uh, no, the let me go back. Oh, we know dp dt, we don't know dx by dt, okay? Right. So I think I misspoke earlier, but the dp dt, the retail price per gallon, is increasing at 0.02. So we know dp dt, that's increasing, so positive 0.02, okay, dollars per week. So we are trying to find the dx dt, so it doesn't matter. Yeah, our calculation is correct, okay? But I misspoke about, the what's known, what's not known. So we have a dp/dt. Either way, I mean, we will have to use this equation. So dp/dt is known. So dp/dt is 0.02. With that, we can find the dx/dt. Okay. So using this equation now, you solve it for this equation for dx by dt. Put these values in, right, for x and dp dt, and you're gonna get we obtain let me call actually this equation here like equation number one. So we obtain from the equation one dx by dt, that's gonna be negative point 3232 million gallons per week. So what does that mean? What it means is that when the price increases, right? When the price increases, the demand decreases. Well, this is the already kind of things that the we experience, right? Okay, price increases, people tend not to spend their money on it. Okay, right? So like say, especially like in this case, the price of oil, is involved. So when the price of gas is increases, we tend to travel less. Okay, unless necessary. So demand is decreasing. Right. That's why we have this negative sign. Okay, here. Okay, so now I think we are ready to and one more thing, we don't know p, right? We don't know p when x equals 10, but that can be also obtained easily from this equation here, right? So when x equals 10, you can easily find p, right? So from this, also from this equation here, right? When x equals 10, you can find the p, right? So p equals actually what square root of 356 minus 10 squared. 10 squared is 100, so that's going to be square root of 256. 256 is what is that? 256 is 16 squared. Okay, so square root of it is going to be 16. So p equals 16 divided by 10. 10. So that's the easy number. So that's 1.6. Okay, so p equals 1.6. So I think that yeah, we have all the quantities required to calculate dr by dt. So dx by dt we know, p is known, x value is known, dp dt are known also. So putting all those values, right? We calculate. So dr by dt, therefore dr by dt, that's going to be, actually, why don't I do that up here? So we've got the values in, so dx by dt, okay, that's going to be the negative 3.32, and then p equals 1.6 plus x equals 10. and then dp dt is 0.02, right? So altogether, we are going to have a negative 0.312, right? 0.312. And the unit is going to be, in this case, million gallons per week. Okay, so we've got the value, and what does that mean? What this means is that the revenue is decreasing by about, the 0.31 million dollars per week. Oh, actually, yeah, I'm sorry. That's not the million gallons. It should be million dollars revenue, right? Million dollars. Okay, so what this means is that the revenue is decreasing by about 0.31 million dollars per week when the price increases $0.2 per week. Okay, right? And so, of course, demand is decreasing, right? Right? Demand is decreasing. So this is something, of course, we expect that demand is decreasing, which means that, people purchase like less, the gas. Uh, so, the revenue also decreases, right? So, it decreases by about, the 0.31 million dollars per week. Okay, so we are going to stop here, and we still have like more examples to go over, but we are going to go over those in my separate lecture video.